Okay, so today we're going to be talking about the graph of the log and the exponential function. Okay, so it's basically just transformations. So here we have this function, okay, the exponential function. First thing you need to decide is what is the parent function for this function? Well, the parent function is the exponential, but specifically the exponential 2 to the x power. Okay, so I always tell my students that when they start off any kind of graphing problem, the first thing you should do is graph the parent function. So 2 to the x power has got the point 0, 1 and the point 1, 2 and the point 2, 4. So I just plug in x's. So 2 to the first power is 2, to the second power is 4, to the 0 power is 1. And you could, if you wanted to, put negative 1 power, which would be 1 half. It has a horizontal asymptote on the x-axis, so my parent function will follow the x-axis and then go through these points, and here's my parent function. Okay? So the next thing is that exponentials are written a little bit differently than other functions. This negative 4 is our vertical shift. The reasoning for that is if you wrote it the other way and you put x minus 3 here and then put the negative 4 afterwards, it could be construed as either this is part of the exponent or something like that, or you'd have to make sure that you put parentheses. But again, mathematicians like to write as little as possible, so by putting the negative 4 ahead of it, I don't have to put the parentheses on the exponent like that. But basically, these are transformations. This negative 3 and this negative 4 are my transformations. They are both shifts. The negative 3 inside the parentheses is my horizontal shift to the right 3, and this negative 4 outside is my vertical shift down 4. So all we're going to do is take these 3 points that we've created from our parent and move them 1, 2, 3, 1, 2, 3, 4. Move them 1, 2, 3 to the right, down 1, 2, 3, 4. 1, 2, 3, 2, 3, 1, 2, 3, 4. Like that. Okay? Now the only other thing that we have to make sure that we move is that the exponential has a horizontal asymptote. Well, the original one's at 0, and when we move this down, it's going to be shifted down to negative 4. So there's our horizontal asymptote. And now that I have the horizontal asymptote, I know that my exponential is going to follow that and then come up, and there's our graph. Okay? So really simple. If you know your transformations, you're basically starting from your parent function and you're just using the transformations that you already know how to do to shift it left, right, up or down, or vertically stretch it. Okay? So now this one, again, we have the exponential, but this parent function is not 2 to the x. This one is e to the x. Okay? So again, I'm going to graph my parent function. And again, it doesn't matter what the base is, 0, 1 is always going to be a key point in the parent function, no matter what the base is. Now, the value of e is 2.71, so it's going to have 1, 1, 2, 2.71 right here. It's basically almost 3. Okay? And again, it has its horizontal asymptote. So here is our parent function. And again, when we look at it, this right here is our horizontal shift, and this is our vertical shift. So this time we're going to the left 4 and up 3. So we start here. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And again, our horizontal is going to be shifted up 3 to right here. And having those points, here is my transformed exponential. Okay? Now, the third one is our logarithm. Okay? So this one is a little different. So we're going to start with the parent function. The parent function for this one is f of x equals log base 4 of x. Now, since it is the inverse of the exponential, instead of having the point 0, 1, it will have the point 1, 0. And instead of having the point 1, whatever the base is, it will have whatever the base is and then 1. So 1, 2, 3, 4, 1. Okay? And instead of having a horizontal, it will have a vertical asymptote. So basically, the parent function for the log base 4, is going to look like that. That's my parent function. Now, let's look at our transformations. This is our horizontal shift. This is a vertical stretch. That is a vertical shift. Okay, so let's talk about our vertical stretch first. Okay, so again, when we start off with this vertical stretch, we're going to multiply our y values by 2. So this point stays exactly where it is because 0 times 2 is 0. This vertical distance is 1. 1 times 2 is 2. So this is our vertical stretch. Okay? Now, we're going to move our points to the right 5 and up 3. So these 2 points, the blue ones, I'm going to go 1, 2, 3, 4, 5, 1, 2, 3. 1, 2, 3, 4, 5, 1, 2, 3. Okay? And again, this time though, I have a vertical asymptote. And that asymptote is going to change when I shift it to the right. So it was right here at 0, but now it's going to move over 1, 2, 3, 4, 5. So it's going to be right here at 5. Which means our final graph is going to come up this vertical asymptote and then go like that. And that is the graph of our log. So basically, there's only really 2 key points. And if you can get those 2 key points taken care of, then the rest of them will just fall in line. Well, and the asymptote as well.